Welcome back to Max with RP. Today we are going to be doing revision on relations and functions pertaining to Class 12 CBSE syllabus. So we will do some important problems which are frequently asked in the CBSE board examination. So the first question that we are going to see is if a relation R on R such that R equal to set of all A comma B such that A is less than or equal to B cube is an equivalence relation. We are going to check whether this is an equivalence relation. So to check something is an equivalence relation, we have to check whether it is reflexive, symmetric and transitive. So even if it fails for one, I would like to check for all the three because it will be a revision for us to check whether this particular relation is a reflexive relation, symmetric relation and transitive relation. If something is true, in mathematics we have to give a proof. If something is false, we have to give a counter example. So let us first look at reflexive property. I am going to choose A to be half. So the question that we are asking is, does A comma A belong to R? That is A related to A? Is every element related to itself? Now, since I have taken A equal to half, if I say A comma A belongs to R, then half should be less than or equal to half cube. That is, half should be less than or equal to 1 by 8. This is a false statement. Therefore, R is not reflexive. So next we are going to check whether it is symmetric. That is, what is the definition of symmetric property? A is related to B should imply B is related to A. For reflexive, A is related to A for every A. This means for every A in R. Now, A is related to B should imply B is related to A. Now, 1 we know is less than or equal to 2 cube. Why 2 cube is 8. What about 2? Is 2 related to 1 cube? That is less than or equal to 1 cube. It's a false statement. So, 1 comma 2 belongs to R, but 2 comma 1 does not belong to R. Therefore, R is not symmetric. The third property that we are going to check is whether it is transitive. So how do you check transitivity? A is related to R and B is related to R. A is related to B, B is related to C should imply A is related to C. So even if it fails for one example, then the statement is not true. So what we are checking, if A is related to B and B is related to C, then A should be related to C. So I am going to choose a particular example. This is done out of trial and error. I am going to choose A equal to 12, B equal to 3, C equal to 2. Now 12 is less than or equal to 3 cube, which is 27. 3 is less than or equal to 2 cube, which is 8. So A is related to B, B is related to C. So Is A related to C? So what are we asking? Is 12 less than or equal to 2 cube? 2 cube is 8, which is a false statement. So A is related to B is related to C, implies A is not related to C. Why? Because we have given a counter example. So we have seen that this relation, set of all R equal to set of all A comma B, where A is less than or equal to B cube, that defines the relationship. It's not an equivalence relation. It is not reflective because I chose A to be half. Half is less than or equal to 1/8 is a false statement. It is not symmetric. 1 is related to 2, but 2 is not related to 1. It is not transitive because 12 is related to 3, 3 is related to 2, but 12 is not related to 2. So it's neither reflexive nor symmetric nor transitive. This is a very important question. They can easily ask either as a 4-mark question or a 5-mark question. Next question. Let Q be the set of all rational numbers. Let Q be the set of all rationals. Now, R equal to set of all x comma y such that 1 plus xy is greater than 0, whether it is reflexive, symmetric and transitive. So Q is the set of all rational numbers and we have to have a relationship R such that x is related to y if 1 plus xy is greater than 0. We have to check whether it is reflexive, symmetric and transitive. So first I am going to check whether it is reflexive. Reflexive. If that means is x related to x for every x in the set. When will x be related to x for every x? If 1 plus x into x, which is 1 plus x square, is greater than 0. We all know that x square is always greater than 0. And this is 1 more than x square. So this is a true statement for any choice of x. Therefore, R is reflexive. Next, we have to check for symmetry. What is it that we have to check? If x is related to y, implies y is related to x. Question mark. Okay. Now, if x is related to y, implies 1 plus xy is greater than 0. If 1 plus xy is greater than 0, then 1 plus yx is greater than 0. Because we are dealing with rational numbers and rational numbers are commutative when it comes to multiplication. So xy is the same as yx. So if 1 plus xy is greater than 0, then 1 plus yx is greater than 0. Therefore, y is related to x. Therefore, R is symmetric. Next, we have to check whether it is transitive. If x is related to y and y is related to z, does it imply x is related to z. This is our question. See, this is the question and we have answered. It is symmetric. So, does 1 plus xy greater than 0 and 1 plus yz greater than 0, does it imply 1 plus xz greater than 0? So, since x is related to y implies 1 plus xy is greater than 0. Y is related to z implies 1 plus yz is greater than 0. From here, can you check whether 1 plus xz will be greater than 0 always? Then you will have to work out or to have some trial and error with some numbers. So I am just taking this example. X equal to minus 1. I am choosing one element as 0 and z equal to 2. Now x is related to y. We will check. Now what is 1 plus xy? 1 plus xy will be 1 plus 0, which is 1. Right? So, which is greater than 0. So, x is related to y. Now, what about 1 plus yz? 1 plus yz will be 1 plus 0 into 2, which is again 1, which is greater than 0. So, y is related to z. Now, is x related to z? Now, look at 1 plus xz. 1 plus xz will be equal to 1 plus minus 1 into 2, which is 1 minus 2, which is minus 1, which is less than 0. So, this is less than 0. So, x is not related to z. So, x is not related to z. So, x is related to x, it's reflexive. X is related to y because 1 plus xy greater than 0 implies 1 plus yx greater than 0. Now, x is related to y and y is related to z. Does it imply x related to z? For that, I have given you a counter example. I have taken x to be minus 1, y to be 0, z equal to 2. 1 plus xy is greater than 0, 1 plus yz is greater than 0, but 1 plus xz is less than 0. Therefore, it fails to be transitive. So, this relation 1 plus xy greater than 0, where Q is a set of all rationals, is reflexive and symmetric, but not transitive. Is it clear? Let's consider the next problem. R equal to set of all A comma B, where A is related to B if A minus B plus root 3 belongs to S, where S is the set of all irrational numbers. So, we are going to check whether it is reflexive, check whether R is reflexive, symmetric and transitive. R equal to set of all A comma B, where A is related to B if A minus B plus root 3 belongs to S. So, first let us check reflexive. That means is A comma A belongs to R. Does A comma A belongs to R for every A? For all A. Okay. Now, if that you are taking from R, look at A minus A plus root 3, which is root 3, belongs to set of all irrationals. Therefore, A is related to A for every A in R. Are you able to follow? If A is related to A, then A minus A plus root 3 must be an irrational number. A minus A plus root 3 is root 3. We all know that root 3 is an irrational number. Next, let us check symmetry. That means what? If A is related to B, does it imply B is related to A? So we are asking a question. So if you get a doubt that it is not true, then you have to give a counter example. So let me choose A equal to 1 and B equal to root 3. Okay. Then what will happen? Or first A equal to root 3 and B equal to 1. Now what will be A minus B plus root 3? That will be root 3 minus 1 plus root 3, 2 root 3 minus 1, which is an irrational number. Therefore, it belongs to S. So, A is related to B. However, if I interchange the roles of A and B, so to check whether B is related to A, let me put A equal to 1, B equal to root 3, then plus root 3, you will get 1. 1 minus root 3 plus root 3 is 1, which is not an irrational number. 1 is a rational number. So A is related to B, B is not related to A. A related to B does not imply B is related to A. Therefore, R is not symmetric. Now, next let us check transitivity. That means what? If A is related to B, B is related to C, does A be related to C? That's the question we are asking. Now I am going to choose A equal to 1, B equal to root 2 and C equal to root 3. Okay. Now let us check whether A is related to B. If A is related to B, A related to B implies 1 minus root 2 plus root 3, which belongs to S. What about B related to C? If I take B related to C, then what happens? Root 2 minus root 3 plus root 3. B is root 2, C is root 3. Replace this by B, this by C. So root 2 minus root 3 plus root 3 gives you root 2, which belongs to S. So B, therefore B is related to C. A is related to B and B is related to C. Now we are going to check whether A is related to C. So is A related to C? If A is related to C, then A minus C plus root 3 should belong to S. So 1 minus root 2. So what are the values of A minus B plus root 3? So I am now taking A 1 and root 3. So 1 minus root 3 plus root 3. What will you get? 1 does not belong to S. So A is related to B, B is related to C, A is related to B because 1 minus root 2 plus root 3 belongs to S. B is related to C because root 2 minus root 3 plus root 3, which is root 2, belongs to S. But if I take A to be 1 and C to be root 3, then I get 1 minus root 3 plus root 3, which is 1, does not belong to S. Therefore, R is not transitive. So, it is reflexive, neither symmetric nor transitive. Is it clear? Now let us look at the next problem. R equal to set of all x such that x belongs to W, 0 less than or equal to x less than or equal to 12 and r equal to set of all a comma b such that modulus of a minus b is a multiple of 4. You have to check whether it is an equivalence relation and you have to find the equivalence class of 2. It was asked in CBSE 2019. Okay. So again, if you have to check whether it is an equivalence relation, you have to check whether it is reflexive, symmetric and transitive. So first let us check whether it is reflexive. That means x must be related to x. Does a comma a belong to R? They are asking. Okay. Now, if a comma a belongs to R, a minus a should be a multiple of 4. It is 0. Is a multiple of 4. We know that 0 is a multiple of 0 times 4. So 0 is a multiple of 4. Therefore, R is reflexive. Next, let us check whether it is symmetric. A is related to B implies modulus of A minus B is a multiple of 4. B related to A implies modulus of B minus A, which is nothing but modulus of minus of A minus B. So if this is a multiple of 4, this is also a multiple of 4. So R is symmetric. So it is symmetric, it is reflexive. Yes. Yes. Next we have to check whether it is transitive. A is related to B implies modulus of A minus B is a multiple of 4. Important step, okay? Then you should write A minus B will be plus or minus 4 lambda for some integer lambda. Okay, now if B, this is A is related to B. B is related to C implies modulus of B minus C is a multiple of 4. So B minus C will be plus or minus 4 mu for some integer mu. Adding A minus B plus B minus C will give you A minus C, which will be what? Plus or minus 4 lambda plus or minus 4 mu. Okay, so modulus of A minus C is a multiple of 4. Therefore, the relation is transitive. Is it clear? Therefore, the relation is transitive. Now, there is one more question. Find the equivalence class of 2. Equivalence class of 2 means what are the numbers among this which are related to 2? Is 2 related to, so among the numbers 0 to 12, what are the equivalence class of 2? What are the elements B which are related to A? When will B be related to A? If A minus B is a multiple of 4. So suppose I take, say for example, 1. So I mean we are finding the elements related to 2. Now let me take 2 comma 0. Is 2 related to 0? Then what will you get? 2 minus 0. It is not a multiple of 4. Then is 2 related to 6? Then what happens? 6 minus 2 is 4, which is a multiple of 4. Then what will be the next number? 10. 10 minus 6 is a multiple of 4. 10 minus 2 is also a multiple of 4. So, if among the numbers 0 to 12, 2, 6, 10, if you take, these will represent the elements related to 2 or equivalence class of 2. Class of 2 equal to 2, 6, 10. 2 minus 2 is 0, therefore it's a multiple of 4. 6 minus 2 is 4, therefore it's a multiple of, since it's a multiple of 4, it's related. 10 minus 2, 10 minus 6, both are multiples of 4. So the equivalence class of 2 is given by 2, 6 and 10. Is it clear? Consider the next problem. A equal to 1, 2, 3. We have to find the number of relations on A containing 1, 2 and 1, 3 which are reflexive and symmetric but not transitive. Okay. So, I already have 1, 2. It should contain 1, 2 and 1, 3. Since it is reflexive, it should contain 1, 1, 2, 2, 3, 3. And symmetric, so it should contain 2, 1 and 3, 1. So now what is left out? 2, 3 and 3, 2. If I add 2, 3, then I have to add 3, 2 because it has to be symmetric. So I'm going to adding 2, 3. I will get what? R equal to 1, 2, 1, 3, 1, 1, 2, 2, 3, 3, 2, 1, 3, 1. Okay, I'm going to add 2, 3. I have to add 3, 2 also because it is symmetric. So it is now makes it. So if I add these two, now what happens to the entire set now? Is it transitive? See, I have 1, 2, 2, 1, 1, 2, 2, 2 is there. 2, 3, 3, 2 is there, which means 2, 2 is there. So, if I add these two, it makes it what? Transitive. So, I can have only, this is the only possibility. So, there is only one such relation. Because these two are left out, if I add one, automatically I add the other because it has to be symmetric, which will make it transitive also. So, this is the only set which satisfies the condition reflexive and symmetric, but not transitive. Is it clear? I hope you enjoyed today's session. We were discussing some of the questions that have been frequently asked in the board exam. We will do in detail some more problems in the next class. So until we meet again, it's goodbye from Maths with RP.